Good morning. We're on page 32 of the note spiral, and we're going to talk about completely randomized design. The recipe for success is merely a guideline and lets you kind of know what you need to have on your free response questions. So first off, the diagram itself, it says random allocation, then we have treatments, and then it says comparing results. And that really is kind of the order of things. So random allocation, that is how you randomly assign your treatments. And whenever you're doing an FRQ uh, for experimental design, you must explain how you're doing the randomization. Typically speaking, we're putting names in a hat, flipping a coin, or assigning all the individuals a number, and then mixing and drawing. But you must be very specific as how that is being done. You can't just say, I'm putting the names in a hat and drawing. If you put the names in a hat and draw, you must say then which group gets what treatment when you draw, and which group gets the other treatment. Then we have the treatments. In this case, we actually only have one explanatory variable, but it has three levels, 1, 2, and 3, treatments 1, 2, and 3. And it could be something like new drug, old drug, and placebo. You must always have two treatments as a minimum. As a minimum, there will be two treatments because you must have something to compare to. It's possible that one of the treatments is the placebo and then something is a new drug or something like that. But there has to be something to compare to. So one could be the control group, and then one could be an actual treatment. Then finally, we have our response variable, and we're going to compare what happened with our response variable. And you need to be specific as to what it is you're comparing. Scrolling down, we have a more complex, a multivariable randomized design. Notice here we're randomizing on two different locations, one's here, one's there, and that is because we have two explanatory variables in this case. We have a treatment 1 and treatment 2, then we have a treatment A, B, and C. So treatment 1 and 2 could be an exercise program. I'm randomly assigning someone to exercise 30 minutes a day, and treatment 2 could be randomly assigning them not to exercise. And then the next treatment will be randomly assigning to maybe a new drug, old drug, and the placebo. And at the end of time, we're comparing results. Obviously, we have three levels with the second explanatory variable. And if we have the first explanatory variable of 2 levels, the next one of 3 levels, 2 times 3 is 6, we see that we have 1, 2, 3, 4, 5, and 6 total treatment groups. Okay. All right, so let's put this into context. So we're now on page 33, and we have the 2007 question 2. As dogs age, diminished joint and hip health may lead to joint pain and thus reduce a dog's activity level. Such a reduction in activity can lead to other health concerns such as weight gain and lethargy due to lack of exercise. A study is to be conducted to see which of two dietary supplements, glucosamine or chondroitin, is more effective in promoting joint and hip health and reducing the onset of canine osteoarthritis. Researchers will randomly select a total of 300 dogs. We have 300 dogs for this. We also know that we're concerned about joint and hip health. And we have glucosamine and chondroitin. All right, those are probably important things as I read along. Researchers will randomly select a total of 300 dogs from 10 different large veterinarian practices around the country. So we have 10 vet practices. All of the dogs are more than 6 years old, and their owners have given consent to participate in the study. Changes in joint and hip health will be evaluated after 6 months. So we know that the experiment's going on for 6 months. And we know that our response variables, what they're comparing at the end, is joint and hip health. What would be an advantage to adding a control group in the design of the study? To my way of thinking, anytime they ask a question like this, it's really good to show them that you understand what a control group is or what the definition is they're asking for. So in this case, a control group, the purpose of a control group is to determine whether or not the changes being observed are due to the treatments or due to variables outside of the study. So we're worried about whether the changes being observed are due to treatments or due to variables outside of the study. To be perfectly honest, that part of the response isn't worth any points. If you only had that, you wouldn't get any points. However, it lets the reader and the grader know that you know what the control group is. And as such, they're likely to give you some flexibility if your answer isn't perfectly worded. So now we're going to put it in context. And you always have to answer these questions in context. Here I have listed 2 contexts. You only need 1. And I would appreciate on your test if you only had 1. So for instance, as dogs age, it's reasonable to assume that their joints will deteriorate. By having a control group, we will know whether or not the treatments retarded the deterioration. So I gave an example of how we know whether or not the treatment was actually working or whether or not it was just because they were aging. So that would answer the question. Or I have part B, which also would have answered the question. A control group would allow us to determine whether joint pain might be attributed to weather. For instance, joints are typically less painful during warm months, so we wouldn't know if the dog's joint pain responses were due to weather or the treatments if there were no control group. Once again, in context, you don't really have to know anything about dogs or joints. Make something up that's reasonable, and that's fine, because really I didn't know anything. I just applied what I knew about humans and called it good for dogs. I'm guessing dogs are humans too, or something like that. I don't know. So part B, assuming a control group is added to the other 2 groups in the study, explain how you would assign the 300 dogs to these groups for a completely randomized design. When we have a completely randomized design, whenever I see completely randomized design, I immediately jump to put everything in a hat and mix. However, I can see it's not that easy to do that with dog names, because the dog names Fido, Fifi, Snowball, Fluffy, Rex, King, etc. tend to repeat themselves, and so there end up being a lot of dogs with the same name. So instead of using their names, I'm going to assign all the dogs a unique number from 1 to 300. So I assigned them all a unique number, and I placed all of the numbers in a bin and mixed thoroughly. And now for the random assignment. The dogs associated with the first 100 numbers drawn would receive glucosamine. The dogs that were associated with the next 100 numbers drawn would receive chondroitin. The remaining 100 dogs would be placed in the control group and would receive the placebo. All right, so I've now addressed them. The order didn't matter if I wanted to do placebo first or chondroitin first. The order wouldn't have mattered. The main thing is I made sure that I assigned all 300 dogs, 100 at a time, to each of the 3 treatments. Finally, rather than using a completely randomized design, one group of researchers proposed blocking on clinics, and another group of researchers proposed blocking on breed of dog. How would you decide which one of these 2 variables to use as the blocking variable? Okay, once again, we need to tell them that we know what blocking is. All right, and we will block on the variable that we believe will have the greatest impact on the study. So would have the greatest impact on the study. So that's how we're choosing the block. Once again, that particular part will not get me any credit, but it provides flexibility in the graders because they know that I know what blocking is. So now I need to put it in context. So the question is, should I block on clinic or should I block on breed of dog? Well, when I think back to humans, I know that if I get sick and go to the hospital, I can pretty much, regardless of the hospital, the protocol for treatment is going to be the same. All right, and I'm going to think that it's going to be the same for animals as well. I really don't know, but this is my assumption. I'm going to tell them that's what I believe, and because I've told them that's what I believe, they're going to accept it. All right, you don't have to be exact. You don't have to be really correct as long as it's plausible. So I believe that clinics across the nation would have similar treatments, and therefore I would not block by clinic. On the other hand, certain breeds of dogs are more susceptible to joint issues, and thus I would block by breed because I believe breed of dog would have a greater impact on the study than a clinic would. And it makes sense to me that I have big dogs and small dogs, and big dogs might have different joint issues than small dogs, and vice versa. And I know that medication differences are going to be different by breed just because of size. So that's why I chose to block by breed. Once again, just using logic based on that and based on what I know about humans and human sizes. So this is the way I would have broken this problem down. Once again, all problems, if you put the definition, that's not going to be any credit, but it gives you flexibility. You know what you're talking about. And then all of a sudden, you put the whole thing into context.